Okay, so there's two things we want to look at here. One is we want to get to where we can recognize what family a particular function belongs to. And then we want to start to be able to recognize how to modify that function into something different. So we'll look at representatives of each family of functions so that when you see a function, at least when you look at it, you can recognize, oh, that's a type of absolute value function. Oh, that is a type of quadratic function. Oh, that is a square root function. And that is the first step to really help you narrow down, to really get to the actual information about that particular type of function. So let's take a look at the different families so we can get used to that. So here we have a constant function, flat horizontal line, right? Think of it as a bank account. If you weren't spending or gaining money, your bank account would just look like a flat line, right? So it's constant. Okay. Then we have the line y equals x, and the line y equals x is a very important graph on its own, but also it's sort of representative of lots of lines, right? The family of lines. Then we have the absolute value function. Absolute value functions look like a V. Now there's many variations on that V, but it generally is going to be, you know, a V shape like we're seeing on the screen here, as opposed to a U shape that we call a parabola for a quadratic. So this, if it's more U-shaped like this, you're thinking second degree polynomial, quadratic. If it's a sharp V, you're thinking absolute value. Okay. Then we see the square root of x, going to look like this. X cubed, this is kind of sort of like a S-shaped graph on its side a little bit. So we've got x cubed, the cube root of x. So those are the families. So you want to get to know those basic shapes. So when you see something that looks like this, you go, oh, that looks like a square root function, right? And you can kind of put them in that family, and then you narrow down the things you have to think about, because you only have to think about the square root functions if that's what you're dealing with. But how do we go, you know, most of the time that you run across a function, it's not going to look just like one of these basic representatives, like an x squared. It's going to look a little bit different. So how do we get from y equals x squared to say something that looks like y equals 3 times x minus 2 squared plus 5. Okay, so on screen right here we see two parabolas, but they're different from each other. So here we have the basic y equals x squared, and here we have this y equals x minus 2 squared plus 5. They're the same basic family, quadratics, but how do we get from one to the other? All right, well, those are what we call transformations. Okay, and the easiest way to deal with these transformations is to just play around with them inside of Desmos. So that's what I've done here. I've got these functions, and then you can put parameters in here, and it'll let you vary these. So see how I can just move these values around? And then you can see what those parameters do to the particular problem that you're working on. So see how I have A, B, and C in here? As soon as you put those in there, like here I'll show you, if I put in, if I say plus D, it's going to ask, do you want to add a slider for D? And you go, sure. And then that allows you to move the D around. But I don't actually want that. I'm just showing you how to put it in there. So that means when I change my values of A, B, and C, it's going to change around the values for this particular function. So let's bring it up where we can look at all of it at once. And I put it up here. And then you can watch as I change these A, B, and C values. So this is what you should do when you're trying to learn these transformations. Put it in Desmos, play around with it, and you'll see what each thing does. So when we just have a plus C on the end, how does that affect my parabola? Oh, it moves it up and down. I see. So you see on the screen we still have our x squared, but now we're looking at a modified version where our C value is changing. So when you change the plus C on the end, it just moves the thing up and down. Oh, okay. Well, what about if I change the B value? We'll see how that moves it left and right. So see how the B is in here, in with the X. Before the operation is being executed, we're adjusting our X value by the amount of B. When you do that, that moves the thing, whoops, sorry, I grabbed the wrong one. That moves it left and right. When I just have the plus C out on the very end, last thing you do for the problem is you add or subtract this value, that moves it up or down. So that's helpful. That allows us to take our base parabola and move it anywhere we want on the graph. You just have to figure out how to shift it horizontally, how to shift it vertically, and it just amounts to putting these two numbers in here, putting the right numbers in there so you get the right kind of shift. What about A? Well, what happens? Let's try it. As I change A, look, it's changing the shape. So I can have a really skinny parabola, or I can have a really wide parabola. Whoops, I went too far. I can have a really wide parabola. And sure enough, if our A goes negative, oh, look, it flips upside down. So we can have an upside down parabola as well. Those are all perfectly legitimate. And see how easy it is inside of Desmos? You just play around with those values and you can really see the transformations happening in real time. And I think that really helps, rather than looking at static pages in a book, seeing and actually being the one moving these around and seeing how that changes things can really help those transformations make a lot of sense. So I encourage you, go into Desmos, make some different versions of your graphs, put in the letters so it'll create those sliders like the way I showed you, and then just play around with these values till they make sense to you. But pay attention to where those values are located in the function, because that's the whole key, is what part of the function is that parameter in. If it's inside the parentheses with the x, it's going to shift things horizontally. If it's the very last thing you do at the end of the problem, it's going to shift it up and down. If it's this A in front, it's going to make it kind of skinny or not. Now watch what happens. Here's the great news. You only have to learn the transformations once because they act the same for all functions, right? Oops, this A should be a 1. The transformations act the same for all of these functions. Let me grab another one, and we'll watch these at the same time. So we have the one that we were just playing with, which was the quadratic. Now we have the absolute value function, and notice they have the same parameters in the same places in these functions, but look what happens now when I change B. Oh, they both move to the left and right. Right? They're both moving left and right because the transformation doesn't care whether you're dealing with a parabola or an absolute value function, it's going to treat them the same way. So when that value see how the B here is inside the parentheses before the squaring is taking place? Here the B is inside the absolute value before you're taking the absolute value. Well, when you change the B value, it moves both of them left and right. When I change the C value, it moves both of them up and down. When I change the A value, they both get skinny or they both get wide. Right? See how that works? So you once you learn the transformations, you know how they will affect all graphs. Even graphs we haven't learned about yet, exponential graphs, logarithmic graphs, these transformations act the same way.